NASA X-43 is one of the most remarkable and ambitious experimental aircraft ever created in the history of aerospace engineering. It represents a revolutionary step in the development of hypersonic flight. Speeds greater than Mach 5 times the speed of sound. The X-43 was part of NASA's Hypersonic program, which aimed to demonstrate air-breathing propulsion at extremely high speeds. The aircraft's small size, unmanned design, and pioneering technology made it a symbol of the future of aviation and space traveler. X-43 program was initiated by NASA in the late 1990s under its Hypersonic project, a part of NASA's broader experimental X-plane series. The purpose was to explore advanced propulsion systems that could push aircraft to hypersonic speeds without relying on traditional rockets. Unlike rockets, which carry both fuel and oxidizer, the X-43 used an air-breathing engine called Scramjet, supersonic combustion ramjet. The Scramjet design allowed the aircraft to use oxygen from the atmosphere, instead of carrying heavy tanks of liquid oxygen. This drastically reduced weight and made the craft more efficient, paving the way for cheaper, faster, and more practical access to space. The NASA X-43 was a small, unmanned winged vehicle, measuring about 3.7 meters, 12 feet in length. Despite its small size, it was packed with cutting-edge technology. The aircraft featured delta-shaped wings optimized for hypersonic stability, a streamlined fuselage designed to minimize drag and resist the extreme heat produced by air friction at high speeds, a scramjet engine that operated efficiently at speeds where conventional jet engines fail. The materials used in the X-body included heat-resistant composites and advanced alloys capable of withstanding temperatures over 10 degrees Celsius, 1832 degrees Fahrenheit. At hypersonic speeds, air molecules hitting the surface create intense heat, and managing this was one of the greatest engineering challenges. At the heart of the X-43 was its scramjet engine, one of the most advanced propulsion systems ever built. A scramjet supersonic combustion ramjet works by compressing incoming air at extremely high speeds. Unlike a normal jet engine, it has no moving parts, such as turbines or compressors. Air enters the engine at supersonic speed, mixes with hydrogen fuel, and burns inside the engine at supersonic speeds. The result is a powerful thrust that can push the aircraft to speeds beyond Mach 7 to 10. The main advantage of the scramjet is that it uses the Earth's atmosphere as the oxidizer, meaning less weight and potentially lower costs for space missions. NASA conducted 3 major test flights of the X-43 between 2001 and 2004. Each test was designed to demonstrate the scramjet engine's capabilities under different conditions. First flight to 001. The first attempt in June 2001 failed when the Pegasus booster rocket malfunctioned, causing the vehicle to be destroyed before reaching its test altitude. Second flight to 004. The second flight, on March 27, 2004, was a complete success. The X-43A was carried by a B-52B aircraft to about 40,000 feet, then launched using a Pegasus rocket booster. Once separated from the booster, the X-43A ignited its scramjet engine and accelerated to Mach 6.83, about 7,000 kilometers per hour or 4,300 miles per hour, maintaining controlled flight for around 10 seconds. Third flight to 004. The final flight on November 16, 2004, broke all previous records. The X-43A reached a speed of Mach 9.6, approximately 11,850 kilometers per hour or 7,310 miles per hour, at an altitude of 33,500 meters, 110,000 feet. This made it the fastest air-breathing aircraft ever flown, a record that still stands today. The X-43 project faced numerous technical challenges. Developing a scramjet engine that could operate reliably at hypersonic speeds was extremely complex. At such speeds, airflow becomes supersonic even inside the engine, making stable combustion difficult. The temperature of the airframe can exceed 10 degrees Celsius, risking material failure. Control and stability become very hard, due to intense aerodynamic forces. Furthermore, testing hypersonic vehicles is expensive and dangerous. The X-43's flights were short, only about 10 to 12 seconds of powered flight, but they provided invaluable data for future research. The X-43 was more than just a aircraft, it was a technological pathfinder. Its success proved that air-breathing hypersonic propulsion is feasible, which has major implications for future space launch systems. Scramjet engines could one day power single-stage two-orbit SSTO vehicles, aircraft that can take off from a runway, reach space, and return without traditional rockets. Military applications. The technology could lead to hypersonic missiles or reconnaissance. Aircraft capable of reaching any point on Earth within an hour. Commercial aviation. In the far future, hypersonic passenger planes could make intercontinental travel possible in under 2 hours. NASA's X-43 paved the way for later hypersonic projects, including Boeing X-51A Waverider, another scramjet-powered test vehicle that reached Mach 9.6 in 2013. DARPA's Hypersonic Air-Breathing Weapon concept, HAWC, NASA's future hypersonic airliner concepts under programs like the Sonic Boom and Next-Gen Supersonic Transport Projects-D. Data collected from the X-43 missions were critical for understanding hypersonic aerodynamics, combustion, and thermal management. Scientists gained insights into how air behaves when compressed and heated at extreme speeds, how hydrogen fuel burns in supersonic airflow, how to design stable flight controls for vehicles traveling faster than Mach 9. These findings continue to influence ongoing research in both civilian and defense sectors worldwide, including in the US, China, Russia, and India, all of which are actively developing hypersonic vehicles. While the X-43 itself was an experimental program, it marked the beginning of a new era in flight technology. Hypersonic research has now become one of the most competitive and strategic fields in aerospace engineering. NASA and other agencies envision future vehicles that could launch satellites more economically, transport cargo and humans to orbit faster than ever before. The dream is to eventually create aircraft that can take off from a runway, accelerate to hypersonic speeds, and reach space without the need for complex rocket stages. The NASA X-43 stands as a milestone in aviation history, a small, unmanned craft that shattered speed records and redefined what's possible in aerospace technology. With its Mach 9.6 achievement, it demonstrated the real potential of scramjet propulsion and laid the foundation for the next generation of hypersonic vehicles. Although its flights were brief, the lessons learned from the X-43 program will continue to influence the design of future spacecraft, high-speed aircraft, and defense systems for decades to come. It represents the human spirit of innovation, pushing the limits of what can be achieved when science and imagination combine. In many ways, the X-43 is not just a plane, it's a glimpse into the future of flight.